if there's other variables involved in the problem. Now, when you look to simplify, now is square root of xy already simplified? Again, all we're testing right now is the index greater than the individual powers. Yeah, so it's already simplified. So if I were to look here and identify, can x even be a negative number? Is it possible for x to be a negative here? If x is a negative, what do you know conditionally about y? If x is negative, then what does y also have to be? Since that product has to be non-negative underneath, or in the radical, you know that if x is negative, then y has to also be negative. What if x is positive? What would y have to be? Positive. So you know that the product xy has to be non-negative, so they either are both positive or both negative. Okay. So when you simplify, you do need to test for this possibility. Okay, let's look at a couple cases. All right, the square root of x squared, y squared. Okay, so again, here the power and index are equal. Okay, that can't happen. You need the index to be greater than the powers. So how many groups of 2 can you remove from the x's? 1. And how many groups of 2 can you remove from the y's? Also 1. Are there any x's and y's left inside the radical when you simplify like that? No. So here's your answer. Again, you can disregard the powers of 1. Hey, do we need absolute values on this? Let's test it. Okay. Can x even be a negative number? If x is negative, you're going to square it anyway, so it doesn't matter, right? X can be positive or negative. If x is a negative number, does y have to be negative itself? No, because y is being squared also, right? So you can have all these different combinations. They can both be negative. X can be negative, y can be positive. X can be positive, y can be negative. Or they can both be positive. All those different combinations will still work, and it'll still give you a non-negative inside that radical. So we only need to test the cases where the x or the y are negative. So let's look at what happens when x is negative. Okay, so when x is negative here, what do you know about y? Does y have to be negative? No, it can be negative or positive, right? Do both of these guarantee non-negative values? A negative times a negative would be, but what about a negative times a positive? It does not. So what do you need around this? You need absolute values. Okay, let's test another case. Okay, x cubed, y cubed inside of a square root. Okay, when you work to simplify this, you're using your index, the 2. How many groups of 2 can you remove from 3? Comes out as 1 with how many x's left inside the radical? 1 left inside. How many groups of 2 can you remove from the 3? Again, 1 comes out, 1's left in. Okay, so here is our expression. When we simplify it, now we have to identify, are there any absolute values necessary? Okay, can x even be a negative number? If x is negative, what do you know about y? It would also have to be negative. That's the only way to guarantee a positive inside. So we need to test that scenario. Again, it's either both negatives or both positives, so all we need to do is test this scenario. So if all of these, the x's and the y's, were all negatives, would this part out here yield a non-negative value or a positive? What about the part inside? Yeah, so do we need absolute values to ensure that? No. So this one would be left just as it is. Is everybody able to see that distinction? Follow? Okay, let's take a look at another example. X to the 5th, y cubed. I want you to see, how would you simplify that, please? Remove from the x's. 2, so that comes out as x squared with how many left over? 1 left inside. How many groups of 2 can you remove from the y's? 1 with how many left over? Okay, so here's your expression. Now you need to figure out, can x's and or y's be negative? Let's test it. If x is negative, what do you know about y? It conditionally has to be negative as well, right? So we do need to test this possibility. Okay, so if x is negative and y is negative, okay, the part inside the radical guaranteed to be positive, but what about this part outside? So what do we need absolute values around in this case? Is the x term on the outside going to guarantee a non-negative? X squared, we're squaring it, so no matter whether x is positive or negative, once you square it, it becomes positive. So what about the y, though? The y does not. So here is what your simplified expression needs to look like. X squared times the absolute value of y times the square root of xy. Right, I want you to try the following 3 questions just really quickly, and then I'll go through them. Or actually, there's just 2 more that I want to look at. All right, I want you to simplify each of those expressions for me, please. For the first one, how many groups of 2 can you remove from the 7, the x's? 3, with how many left over? 1. How many groups of 2 can you remove from the y's? 1, with how many left over? Again, that terminology that I use there, I'm going to use when we're dealing with cube roots and fourth roots as well. That's why I use that terminology. Let's test these. Can x even be a negative? If x is negative, what do you know about y? Again, it's locked into being a negative as well. So let's test what happens here. Okay, so if x is negative and you cube it, you get a negative times a negative gives you an overall positive out here. A negative times a negative gives you an overall positive inside. So is this guaranteed to be non-negative the way it is? Yeah, so there's no need to do anything else. That is the simplified form. Okay. This last example. Okay, how many groups of 2 can you remove from the x's? 1 with how many left inside the radical? Nothing left inside. How many groups of 2 can you remove from 3? 1 with how many left inside? 1. So let's test this. Can x be a negative? Yeah, if x is negative, does it lock into place what y is? Not specifically, but what do you know about y? Can y be a negative? It's odd power. There's no way y can be a negative. So here's the only 2 possibilities here to test. So let's say we test x is negative, y is positive. Does this form yield a non-negative, just the way it is? A negative times a positive times the square root of a positive? No, you do have to consider x has to be a non-negative, so what do we need around the x? Okay, so just around the x is an absolute value. Again, you cannot just put absolute value around everything every time and think that that covers it. And you need to be able to distinguish when they need to or don't need to be there.